Let us recall what is Laplace transform. Recall uh, Laplace transform of a function f of t is denoted by L of f of t, which is equal to integral 0 to infinity e raised to minus st f of t dt. And this integral must be a function of s, and we denote it by f of s. And also we know that Laplace transform of is linear, that is a into f of t plus b into g of t is equal to a into L of f of t plus b into L of g of t. Okay, so this is a property, linearity property. Now let us do first shifting theorem. So write down what is first shifting theorem. The first shifting theorem states that if f of t has the transform, that means has the Laplace transform capital F of s, then Laplace transform of e raised to at into f of t. So Laplace transform of f of t, that means if L of f of t is equal to f of s, then Laplace transform of e raised to at f of t is equal to f of, instead of s we will write s minus a. So this is Laplace transform of e raised to f of t. Okay. So I am not doing the proof. I have already shared a video where I have done the proof. Now we will do problems. So an example. First we will do an example. Example. What will be Laplace transform of e raised to at cos omega t? So tell me what is Laplace transform of cos omega t? Anybody? You have to study these formulas. What is Laplace transform of cos omega t? Anybody? Laplace transform of cos omega t. So I have shared a photo in your WhatsApp group. Please, this Laplace transform of cos omega t. Anybody tell me? It's s divided by s square plus omega square, right? S divided by s square plus omega square. Then what will be Laplace transform of? Okay, we have to find this, right? So we know that Laplace transform of e raised to at f of t by first shifting theorem, it is f of s minus a, which implies Laplace transform of e raised to at cos omega t is equal to, here in the place of a itself, right? A. So f of s minus a. So f of s is, this is f of s. Then instead of s we have s minus a. So s minus a divided by s minus a whole square plus omega square. So this is Laplace transform of e raised to at cos omega t. Similarly, we can do find Laplace transform of e raised to t sin 2t. So here uh, we know that Laplace transform of sin 2t is equal to, here it is 2. Instead of omega, here it is 2 by s square plus 2 square, right? Then by first shifting theorem, L of, we know that L of e raised to at f of t is equal to f of s minus a. So here a is equal to 1 and omega is equal to 2. So here omega is equal to 2. Therefore, L of e raised to t sin 2t is equal to, we will replace s by 1. So that is 2 by s plus 1, sorry, 2 by s minus 1 all square plus 2 square. Now you do a problem. Next problem. Third problem. Find Laplace transform of t cube into e raised to minus 2t. So Laplace transform of t cube e raised to minus 2t, L of e raised to minus 2t t cube. Okay, so here we know that L of t raised to n is equal to n factorial divided by s raised to n plus 1. So from the table, we will get L of t raised to n is n factorial divided by s raised to n plus 1. Then L of t cube is equal to 3 factorial divided by s raised to 4. Okay. Now, it's in place. L of e raised to minus 2t, we will use first shifting theorem, t cube is equal to, so here in a is equal to minus 2, right? So we will replace s by s minus minus 2. So this is 3 factorial divided by s minus minus 2 all raised to 4. That is equal to 3 factorial divided by s plus 2 all raised to 4. So this is Laplace transform of. Now we will do one more problem and we will move to inverse Laplace transform. The next problem, okay, so three, uh, fourth problem, find the Laplace transform of sin h t cos t. And we know that we have Laplace transform of f of t. A into f of t plus b into g of t is equal to Laplace transform of a into Laplace transform of f of t plus b into Laplace transform of g of t. So this is linearity. But L of f of t into g of t, this may not be equal to L of f of t into L of g of t. So we cannot use this. Okay. So we already know that L of h of t and L of cos t, but it doesn't follows the multiplicative property. L of f of t into g of t that not equal to L of f of t into L of g of t. So, but we know that sin ht is equal to e raised to t minus e raised to minus t divided by. So now I can write L of sin ht cos t is equal to L of e raised to t minus e raised to minus t divided by 2 into cos. So now I can take a constant outside 1 by 2 by using this linearity property 1 by 2, and I can write L of e raised to t cos t minus L of e raised to minus t cos t. Now this is equal to 1 by 2 times L of e raised to t cos t. L of cos t is equal to, we know that it's s by s square plus 1 square, and this is a equal to 1. So I can replace s by s minus s plus s minus 1, s minus 1 divided by s minus 1 whole square plus 1 square minus, here instead of a equal to minus 1. So s plus 1 divided by s plus 1 whole square plus. So this is the Laplace transform of sin ht into cos t. Now I will give you few homework today. Now next we will move to inverse Laplace transform. So we have already studied Laplace transform of many functions, and now we can also find the inverse Laplace transform. Okay, so inverse Laplace transform is inverse Laplace transform. Inverse Laplace. So inverse Laplace transform, if L of f of t is equal to capital F of s, then L inverse of f of s is equal to f of t. So if you have given f of s, you can find f of t. Am I audible? And now, okay. Now we will do few problems. First problem: find inverse Laplace transform of first question, 5s plus 1 divided by s square minus 25. This is our first question. So now we want to find out what is inverse Laplace transform of this one. So we have to find L inverse of 5s plus 1 divided by s square minus 25. So this is equal to by looking into, we want to convert it into the form of some known Laplace transform. So this is 5s divided plus 1 divided by s square minus 25 is actually 5 square. Now I can write it as, because of the linearity, I can take L inverse of, I can take 5 outside. L inverse of 5 into L inverse of s divided by s square minus 5 square plus L inverse of 1 by s square minus 5 square. Okay. 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 Now we know that L of cos 5t is equal to, we know that L of cos 5t is equal to cos h 5t is equal to s divided by s square minus 5 square. L of cos h 5t is s divided by s square minus 5 square, right? So now if we take the inverse Laplace transform, therefore L inverse of 5s plus 1 divided by s square minus 5 square equal to 5 into L inverse of s divided by s square minus 5 square plus L inverse of 1 by s square minus 5 square. Now this is 5 into, this is cos h5t plus, now here L of sin h5t is equal to 5 divided by s square minus 5 square. Okay. Now I have here L inverse of 1 by s square plus 5 square. So I am taking 1 by 5 outside plus L inverse of 5 by s square minus 5 square. So this is 1 by 5 into 5, 1, right? So this is 5 cos h 5t plus 1 by 5 times L inverse of 5 s square minus 5 square is sin h 5. So this is the, now similarly we can do many other problems. So anybody have any doubt? Any doubt? So let us move to second problem. Find inverse Laplace transform of, so you do this problem. S divided by s raised to 4 minus 48 divided by s raised to 6. The solution is, you have to find L inverse of s divided by s raised to 4. Sorry, it's not s, it's 2. 2 divided by s raised to 4 minus 48 divided by s raised to 6. So what we have to do? first we will split this Laplace transform. This is L inverse of actually 2 divided by S raised to 4, right? S raised to 4 minus L inverse of 48 divided by S raised to 6. Now I can take 2 outside here. 2 into L inverse of 1 by S raised to 4 minus 48 into L inverse of 1 by S raised to 6. Now we know that L of t raised to n is n factorial divided by S raised to n plus 1. Okay. So L of t cube is equal to 3 factorial by S raised to 4. Now if I want here 3 factorial, right? Here. So in order to get that, 2 divided by 3 factorial into L inverse. So we can write here 3 factorial divided by S raised to 4. Have you got it? Now similarly, here there is S raised to 6 one. So we know that L of t raised to 5 is 5 factorial divided by S raised to 6. So I want 5 factorial here. So I am dividing 5 factorial, 5 factorial, L inverse of 5 factorial by S raised to. Now I can write 2 divided by 3 factorial. L inverse of 3 factorial S raised to 4 is t cube minus 48 divided by 5 factorial. L inverse 5 factorial divided by t raised to 5. Hence, Laplace transform of this function is. Now, now we will do another problem. Okay, so listen carefully. So you have to first you have to study all those formulas, then and this will be easy. Okay, find Laplace transform of find Laplace transform of minus s plus 11 divided by s square minus 2s plus 2s minus. So, solution, we have to find L inverse of minus s plus 11 divided by s square minus 2s minus 3. So in the denominator, here there is s and here there is some constant, and in the denominator it is something like s square minus 2s minus 3. Okay, so in the numerator, if there is s and a constant s plus, or a constant times s plus something, a constant, we will convert it into, like, this can be written as, we can use first shifting theorem. So this is minus s11 divided by, I can write this as s square minus 2s plus 1. Okay, I am adding 1 minus 3 minus 4, minus 3 minus 1 minus 4. So I can write like this. Why? Because if I am writing like this I will get minus s plus 11 divided by s minus 1 whole square minus 2 square. So this is something like a first shifting theorem. So for that, I can again, here it is s minus 1. Okay. So I want minus of s minus 1 I need. So I am writing s minus 1. So minus of s minus 1 is plus 1 plus I'm taking 1 here. So that is equal to 10. So 10, 11 minus 1, 10. And I am adding 1 divided by s minus 1 all square minus 2 square. So anybody have any doubt? Please ask me if you have any doubt. Please. Now I can split L inverse of, I'm taking minus 1 outside, s minus 1 divided by s minus 1 all square minus 2 square is equal to, okay, plus here it is 2 square. So I'm taking this 10 I can written as 2 into 5. So 5 L inverse of minus of s minus 1 plus, sorry, 2 divided by s minus 1 all square minus 2 square. So this is equal to L of, we know that L of cos 2t is equal to s by s square, sorry, cos h 2t. H 2t is 2 square. L of e raised to t cos h 2t is s minus 1 divided by s minus 1 all square minus 2 square. Similarly, L of sin h2t is equal to 2 divided by s square minus 2 square. L of e raised to t sin h2t is equal to 2 divided by, instead of all square minus 2 square. So now I can write minus of minus 1 divided by this. This is actually e raised to t cos h 2t plus 5 times L inverse of 2 by 5. So this is e raised to t sin h 2t. So this is the answer. Or you can simplify this also. You can either e raised to minus t into cos h t 2t, you can written as cos h 2t is e raised to 2t plus e raised to minus 2t divided by 2 plus 5 times e raised to t into e raised to 2t minus e raised to minus 2t divided by 2. So you can simplify this. So here we are taking inverse Laplace transform of first shifting property. So now we will do more problems. Sometimes we cannot do this. if okay, if our uh, I will do some other problems where we will use partial fraction. So next problem is find inverse Laplace transform of L inverse of 2s square minus 6s plus 5 divided by s cube minus 6x s square plus 11s minus 6. And what we will do is solution. So I have to simplify this. So I can write 2s square minus 6s plus 5 divided by s cube minus 6x square plus 11s minus 6 is equal to by partial fraction, or this is equal to 2s square minus 6s plus 5. The roots of this polynomial is you can use calculator, is equal to 1, 2 and 3. Okay, so I can write this as s minus 1 into s minus 2 into s minus 3. So now I will use partial fraction a by this 2s square minus 6s plus 5 divided by x cube minus 6x square plus 11s minus 6 is equal to a by s minus 1 in plus b by s minus 2 plus c by s minus 3. Okay. So now if I know what is a, b and c, you can easily find the inverse Laplace transform. So in order to find uh, a, b and c, we will use simplest. I'm cross multiplying and I will get 2s square minus 6s plus 5 is equal to a into s minus 2 into s minus 3 plus b into s minus 1 into s minus 3 plus c into, if we are cross multiplying, c into s minus 1 into s minus. This is equation number 1. In order to find a, b and c, first put a is equal to 1 in equation number 1, which implies is equal to 1. 2 minus 2 into 1 square minus 6 into 1 plus 5 is equal to a into 1 minus 2 minus 1 into 1 minus 3 minus 2 plus this is 1 is equal to 1, this 0, 0, which implies 4 2 minus 2 minus 6, okay, 2 into 1 square 2, 2 minus 6 plus 5, 7, 7 minus 6, 1, right? 1 is equal to 2, 2, which implies a equal to 1 by 2. Okay. Now put s equal to 2 in equation number 1. into 2 square minus 6 into 2 plus 5. 0 plus b into s2, then 1 minus 1 plus 0. Simplifies. This is 2 square, 2 into 2 square, 8. 8 minus 12 plus 5. 13 minus 12, 1 minus b. So b equal to minus 1. It is equal to s equal to 3. So 2 into 3 square minus 6 into 3 plus 5 equal to, okay, so that is if I put s equal to 0, sorry, s equal to 3, so a, this becomes 0, a into 0 plus b into 0 plus c into 3 minus 1, 2 into 3 minus 2, 1. So this is 2 into 3 square, that is 9, 2 into 9 minus 18 plus 5. 18, 5. So this is 5 equal to 2c, c equal to 5 by 2. Now, now a equal to 1 by 2, b equal to minus 1, c equal to 5 by 2. So we got, we have to find L inverse of 2s square minus 6s plus 5 divided by s cube minus 6s square plus 11s minus 6 is equal to L inverse of a 1 by 2 divided by s minus 1 plus b is minus 1 divided by s minus 2 plus 5 by 2 divided by s minus 3. So you can write it as 1 by 2 times L inverse of 1 by s minus 1 minus L inverse of 1 by s minus 2 plus 5 by 2 L inverse of 1 by, so this is equal to 1 by 2 times e raised to 1 by s minus 1 is e raised to t minus e raised to 2t plus 5 by 2 times e raised to 3t. So this is the answer. So I will give you more questions and then you just do all those problems. Okay. So I will give you a homework. And there is one more topic we have to cover today, that is Laplace transform of derivatives. So third section is Laplace transform of derivatives. The Laplace transform of derivative, that means L of f dash of t, derivative of f of t is equal to S into Laplace transform of f of t minus f of 0. So that is Laplace transform of derivative. Okay. And similarly, you can write Laplace transform of second derivative of t is equal to s square Laplace transform of f of t minus s into f of 0 minus f dash of 0. The Laplace transform of second derivative of f of t is, so please note it down. Now in general, Laplace transform of nth derivative of t is equal to s raised to n Laplace transform of f of t minus s raised to n minus 1 f of 0 minus s raised to n minus 2 f dash of 0 minus etc. minus f raised to f n minus 1 the derivative of 0. So this formula, this note this formula. So if we want to do a problem, why it is important? Because if we want to do a problem like find Laplace transform of t into cos 40, so we know that okay, so here we want to find the Laplace transform of t into cos 40. So here f of t is t into cos 40. Now f dash of t is minus 40 okay minus 40 uh, sin t. Okay, okay, this is your homework. I will write do a simpler problem so that it will be easy to understand. Okay, so find the Laplace transform of t into e raised to at. So f of t is equal to t into e raised to at. F dash of t is equal to t into a e raised to at plus e raised to at. F double dash of t is equal to, okay, or now L of f dash of t, we know that s into L of f of t minus f of 0. So this is equal to L of t a e raised to at plus e raised to at s into L of t e raised to at minus 0. So this is equal to a L of t e raised to at plus L of e raised to at is equal to s into L of t e raised to at. I am taking this the other side. You can write it as S minus A into L of t raised to at is equal to so 1 1 this this is equal to 1, right? It's minus, okay, S minus A L of t raised to at is equal to L of e raised to at. So this is equal to L of t e raised to at S minus A L of e raised to at is 1 by S minus A, right? So which implies L of t raised to at is equal to 1 by S minus A whole square. So this is the answer. So now you do this problem. L of t cos to 40. So find Laplace transform of, this is your formula, t cos 40.